All right, everyone. Miss you guys. Hope you're doing well and you're safe and actually not sick. This is going to be the first video of our COVID-19 shutout period. As I said before, we are going to start with the 7.4, 7.5 sections. I did assign them prior to as busy work to get you, I guess, doing something while we waited for more information about what's happening in this city or this country rather. But now you are officially responsible for it, and we'll go from there. Please note, there are a couple of things I do want to mention before we begin. Just preliminary logistical things. Number one, please follow the instructions that you see in the Google Classroom. If there's a video for you to watch, please watch it. If there is a video for handout filling in, please do so and fill in accordingly. Also, number three, tell your friends that this work has begun, that they need to get started. Especially if I missed them, although I probably didn't, they should know that all their friends are getting started on it too, so they don't sort of miss out. Number four, I am going to be posting this work on the Wednesdays, just because I have my first grade 9 classes on the Wednesday section, which means you don't have too much time before the weekend to actually try it. I'm going to allow you some time to try the work that I have assigned throughout the week, on the Wednesday, sorry. And I will hold an office hour or a tutorial session where you can pop in and ask questions live. I am going to open up a Google Meets meeting. I will put up the link to the Google Meets on our Google Classroom somewhere, minutes before the actual hour I hold it. If you are interested or you have questions to ask, please check minutes before the actual hour itself. Click on the link, join me, and follow the instructions about your mic and camera being off and muted, because number one, you don't want to sort of have an invasion of your privacy. You may not want people to see you or your room or whatever. And number two, if your mic is on, you may continually interrupt or get in the way of other people might be asking questions already. You can communicate to me and ask your questions through chat. All right. Also, you may want to, just give it a go. You may want to bring out a paper and pencil so that you don't have to constantly watch these videos again and again. As I'm sure you know, in videos, you do not want to watch the entire thing because it's a waste of your time. There's a lot of filler space and time. Instead, you want to write down the parts that you think are most important and refer to your notes afterwards. Constantly looking at a video for study is a huge waste of your time. You will learn that very, very soon if you don't know already. Okay, so take out a pencil and paper. You may want to copy down notes as we go. We are going to start with 7.4, and that is midpoints and medians in triangle. Our goal for this lesson is, number one, identify by definition what the heck is a midpoint, what the heck is a median, see what that is visually, see what that is inside a triangle. But more than the definition itself, your goal is to connect and apply those definitions and know the implications of what these mean in a triangular relationship. Okay, I'll say it again and again in this lesson. It is not enough for you to know the definitions of these. I don't care about the definitions. I want to know that you understand the implications, the applications. Okay, so let's get to it. Starting with the definition itself. What the heck is a midpoint? Really not that hard. It's as it sounds. Let's pretend I have a line segment. That is line segment A, B. Let me label it with A and B. The midpoint is literally a point that is directly in the middle of A and B. What does that mean? The line segment A to the middle and B to the middle are perfectly equal. Just because it's called midpoint, I will call this point M, and I will make a little reference saying this is the midpoint of line segment AB. That's it. That's pretty much it. That's the midpoint. What does that also mean though? Well, where do you see line segments? Anytime you see line segments, we can make use of midpoints. So I'm going to try to draw an identical line, but use this line as part of a larger triangle. And this triangle has vertices A, B, and C. Anytime you see a line segment, even if it's part of a larger shape, the midpoint still can apply. So assuming this is directly in between A and B, that is also called a midpoint. And to further our knowledge, here's a line segment AC, so there must be a midpoint that divides perfectly in between. And line BC, there must also be a midpoint that perfectly divides B and C. Those three are all midpoints. Ta-da, we're done. Let's talk about the definition of a median. Well, since we're in a triangle, I'm going to use that to segue perfectly to our idea of median. Median is, from a midpoint, I am going to connect to the furthest vertex, not to A, not to B, but the vertex furthest away from the midpoint. Here is what I would call median CM. So that right there is median CM. Okay? Ta-da! That's the median. And of course, you might ask, well, what about the other lines then? Yeah, the same applies. PA, or AP, is another median of this triangle. And BN is another median of this triangle. Oops, I went off a little bit. Okay, all three are medians. Food for thought. In the future, you might notice that all three medians happens to intersect each other at a single location in the triangle. That point is actually something special, but we won't have to worry about it just yet. Something in the future, something to think about, okay? All three medians, there are three medians in a triangle. Just to make this official, let's type out some definitions. Midpoint. Midpoint is, very shortly, a point that divides a line segment perfectly in two equal parts. Done. Median. A median is a line segment that divides, oh, and here's a math word, or bisects, the area of a triangle in two equal parts. At this point, you might think, whoa, Mr. Kim, since when did you start talking about area? There was nothing about area in your explanation. You only said a median was from a midpoint of one side connecting to the furthest vertex. And you know what? You're right. I didn't mention anything about the area of a triangle. But you know what I said about implications? There's a big implication in drawing a median. A median, in fact, does cut the area of a triangle into two equal parts. One explanation, know what I mean? Here is what I mean. Let's try to keep it simple for the first example. I'm going to draw an equilateral triangle. Bear with me. I know it's not perfect, but let's pretend it's an equilateral triangle. As an equilateral triangle, I'm going to draw in my midpoint. And if I draw a median from that midpoint, you will see that it creates a 90 degrees with the base. Okay, as it would be for an equilateral triangle. Just for the sake of labeling, here is A. Let's call that B. Let's call that C. And this is midpoint M. Cutting the area of a triangle in two equal parts, I can prove this by going back to our formula of a triangle, area of a triangle. Okay, please take a look. I took triangle ABC and I cut it into triangle AMC. And triangle BMC. So there is a blue and a purpley pink side of the triangle. And I can prove that the area, the area of AMC is equal to the area of BMC. Really? You might want to argue. Again, let's turn the area of AMC into its formula. Half base times height. Is it truly equal to half base times height? Well, let's take a look. By definition of a midpoint, I know that AB is cut perfectly in half. So the length of AM is going to equal the length of BM. What does that mean about the base? That means the base of AMC is right there, and the base of BMC being right there. They are equal to each other. Base, they're equal. What about the height? Well, I think you can guess. The height of AMC is from M to C. And the height of BMC is from M to C. In other words, H and H, they're equal. And of course, half is part of the equation. Half is going to be half, and they're going to be the same. In short, the area of one triangle and the area of the other triangle is perfectly equal thanks to our definition of the median, or that is causing the definition of the median. Well, you might ask then, what about a more complex example? Does this situation occur for any difficult triangle? And I'm going to say yes. Let me draw an obscure triangle for you. Maybe this is a little too obscure. There you go. There's one. Why is it still black? What if I had a triangle that looked like this? Like that. And there is my A, there's my B, and there's my C. Okay. Hope you're still following along with me. If you want to write this down, that's fine. This is my midpoint M, which means AM and BM are the same. And there is a line median connecting M to C. Just to make it easier on your eyes, I will continue coloring these triangles. That is the blue, and here is the purpley pink. Okay, so is it still true that the area of AMC and the area of BMC are equal? Is the area, I need the black color, is the area of AMC still equal to the area of BMC? Well, once again, half base times height equals half base times height. Is it true? What is the base of triangle AMC? Right there. What is the angle, what is the base of triangle BMC? Right there. And thanks to our definition of midpoint, we know that AM and BM are, again, going to be equal. What about the height? Well, the height of AMC goes as far as vertex C. That is the height of my triangle AMC. What about BMC? What's the height of BMC? Well, it's the same vertex. It goes as high as where point C is. In other words, even though the height may be outside of the triangle, the heights of both triangles are the same. And of course, the half is half. There's nothing different about it. We can prove that the median always cuts the area of a triangle perfectly in half. We just proved it. Okay? What do you think? That is a deep implication of what median can do. But we spent a lot of time talking about median. I want to say something very quickly about the midpoint as well. So I'm going to draw a little divide. You may not have to do this just because you have a piece of paper. Okay. One last note. about midpoints. Understanding the midpoints isn't just about cutting a line in half. It does some interesting things to a triangle. I'm going to draw some random triangle once again. And I'm going to identify the midpoints of the two sides here. And please note, you're going to have to assume that these two are in fact midpoints. If I were to connect these midpoints, you will see that it creates a parallel line with the furthest away side of that triangle. What do I mean by that? Let's give it some points. M, N. This cuts perfectly in half. This is cut perfectly in half. When you connect two midpoints of a triangle, you effectively create similar triangles. Here's a small triangle, and here's a larger triangle. They are proportional to each other. The mathematical word for that is they are similar. Okay? Another way I could prove it is the fact that because these two lines are parallel, we know that the inner angle here and that inner angle are going to be equal thanks to parallel line theorem F. And same thing, this angle and that angle are going to be equal thanks to parallel line F. And of course, that angle is going to be shared. But without getting into too much of that, because you could probably argue about it easily on your own, I'm going to remove these and give you some examples of what the implications of the midpoints are. We can say that, let's pretend line segment AC has a length of 10. That means, being cut perfectly in half, these two line segments are going to be 5 and 5. In the same way, on the right side, if I have a line segment BC being 12, that means this side is going to be 6, and this side is going to be 6. Well, what does that mean? Knowing that these two triangles are proportional to each other, and that these two sides are cut perfectly in half, by definition, when the lines are connected to, when the midpoints are connected, that means the same ratio can be said of the two parallel lines. If the line segment of AB was 14, then line segment MN would be exactly half. It would be 7. Thoughts? Pause the video now and sort of digest it. I'm going to go on to page 396, example 1. Just to give you an idea of how we can use these pieces of information to help us talk about triangles. So again, the question gives you an example of a cottage roof. Often are built in the shape of an A-frame because there's a lot of snow. And I will label this as A, B, C. There, from a midpoint to a midpoint, there is a line that's going to be parallel. This is 3, that's 3. This is also 3, 3, and the sides are 6. There's also lines that are going straight down, creating a 90 degree and a 90 degree. Okay, and so the midpoints are D and E. So we have 6. The line segment AB is cut into 3 and 3, which means this total side is a 6. And the other side is also a 6. Lord of mercy. Yeah, I don't know who designed this question, but I don't know why they had to make it 6, 6, and 6. Wow. Maybe I should edit this from the video. Whatever. It's from the textbook. Okay. One last piece of information is 2.5 and 2.5. What can we say about these questions? Take a look at what they ask you. Question A asks, find the width of the floor of the upper room. Find the width. In other words, find how long DE is going to be. Well, Knowing that D and E are midpoints, when I connect them, I can say it is directly half of BC. In other words, it's going to be directly half of 3. There's no arguing. There's no directly half of 6, which is going to equal 3 meters. There's no arguing. Because these are midpoints, we can argue that DE is going to be exactly half of BC. Because the smaller triangle is proportional to the larger triangle. If the longer side is a 6 and the smaller side is perfectly half, the longer side is a 6 and the smaller side is perfectly half, then the longer side is a 6 and the smaller side is going to be perfectly half by similar triangles. Question B. Find the height of the upper room. Find the height. Once again, because they are similar triangles, we can argue that the height of this is going to be double the height of that by similar triangles. So if the height to halfway is going to be 2.5, then the height of the entire triangle is going to be approximately 5, which means the height of the upper room is going to be 2.5 meters tall. That's it. So again, the implications of a line connecting midpoints, you can say a lot about the measurements of a triangle, even without information directly given to you. But that is something you have to get used to, and that is something you're going to have to master. That is something that I hope you'll be able to identify and argue, even without having to recall definitions. Please practice questions so that you can argue these points without having to recollect information from a textbook like you or some computer. All right. My homework for you for chapter 7.4 is going to be page 398, numbers 1 to 4, 7, and 8. Try them. As well, you may want to keep a formal notes in hand. If you take a look at the Google Classroom, there is going to be a post with a blank sheet that you need to fill out, along with the video from a colleague, another math teacher in Northern Secondary, that is going to help you fill through that. Please be responsible and go through the motions. It will help reinforce this information. We will see you in the video for 7.5. Work hard. I trust that you will do well. If you have any questions, email or find me on the Google Meets. See you soon.